Hey, and welcome to another episode of OpenSec. Today we're going to be talking about simplifying like and unlike terms. Now we all know these numbers and letters can be a bit intimidating, but don't panic, it's just math. So let's put these away for now and let's look at a real life scenario, which we in the Caribbean will be a bit familiar with: buying doubles. So it's Sunday morning and your family goes to buy their favorite doubles from their favorite doubles man. Now you all want doubles, but each of you orders something slightly different to eat on the spot. Your sister orders 2 doubles, your mother orders 3 doubles, and because you are a little greedy, you order 5 doubles. Now it's time to pay the doubles man. How do you know how much to pay him? Well, you could tell the doubles man the different orders separately, but that could be a bit confusing. Instead, because you all ate doubles, all you have to do is simplify the order by adding each number of the doubles eaten all together. 2 doubles plus 3 doubles plus your 5. 5 doubles simplified equals 10 doubles. The family has to pay for 10 doubles altogether. Simple enough, right? Well, in this example, because each family member ordered doubles, they all ordered like items, or as we would say in maths, like terms. But let's say the orders were a bit different. Let's say Pops came into the equation and he was in line and he was even greedier than you. So he ate 5 sahinas for himself and then he ordered another 3 sahinas to carry home for later. Now the order is a bit different. So when it is time to pay, you now have to pay for 10 doubles from earlier on, plus the 5 sahinas which he ate on the stand, plus the 3 sahinas that he bought to take home. This makes the order even more complicated. So simplifying it a little bit from here will be a little bit different. Because sahinas are different from doubles, or as we say in maths, sahinas and doubles are unlike terms, they must be dealt with separately. So when this order is simplified, what you pay for is 10 doubles and 3 plus 5 sahinas. 3 plus 5 equals 8. So the order is simplified. It's 10 doubles plus 8 sahinas. I don't know about you, but now I'm real hungry. So let's hurry up this video so we can go and eat some doubles. Let me go.
You go ahead and eat your doubles. I could take it over from here. It's me, Abby. Now remember those little expressions from earlier? The one with the letters? Well, it's the exact same thing. The letters in algebra aren't there to confuse you. They are there as stand-ins or substitutes for values we do not know. In math, these are called unknowns or variables. So the next time you have to simplify these intimidating looking algebraic expressions, think of x's and y's as doubles and sahinas. So if x's are doubles and y's are sahinas, all x's are like terms with other x's and all y's are like terms with other y's. So just as we did with doubles and sahinas, we do with x's and y's. So 2x plus 3x plus 5x equals 10x, and 2x plus 3x plus 5x plus 5y plus 3y equals 10x plus 8y. And don't panic. If the orders of the letters are different, simply group the like terms together, and just as we learned in other previous video on directed numbers, be sure to keep their signs the same. Example, 2x minus 8y minus 6x plus 1y will be equal to 2x minus 6x minus 8y plus 1y. See how negative 8y maintained its negative sign even when moved to the end of the expression. Now, let's simplify the equation even further. 2 minus 6 equals negative 4 and 1 minus 8 equals negative 7. Therefore, 2x minus 6x plus 1y minus 8y is equal to negative 4x minus 7y.
Now that was done real good though. Alright, ready for more work? So now that we understand adding and subtracting like terms, let's look at multiplying and dividing them. But before we do so, we need to introduce a new idea. Have you ever heard of something like 2x to the power of 2 or 2x squared? Well, we know the letter x is called an unknown or a variable. But what about the other 2 parts? Well, the large 2 to the left of the letter is called a coefficient, and the small 2 on the top right-hand corner of the number is called an index or a power. All 3 together is called a term. This term is read as 2x squared or 2x to the power of 2. This is important to know when it comes to multiplying and dividing like and unlike terms.
Before we get into that, please note that just as the plus sign is sometimes invisible in positive numbers, the index 1 or power 1 is invisible on the top right corner of the unknowns. For example, 2x is actually 2x to the power of 1. It is also important to note that even though 2x and 2x squared both contain x's, they are not like terms. For terms to be like, they must not only have the same unknowns, they must also have the same index or power. Therefore, 2x plus 2x squared plus 5x is not equal to 9x squared. It is actually equal to 2x squared plus 7x. Keep these in mind as we go forward.
Alright, back to multiplying and dividing. The rules are simple. Earlier we said 2x and 2x to the power of 2 are unlike terms that cannot be added or subtracted from each other. However, they can be multiplied and divided against each other. Let's look at this expression when multiplying powered terms.
You're not forgetting something?
Am I?
You're forgetting the secrets.
The secrets. Oh, the secrets. Yes, this expression has a couple secrets. The first is this. It may look like the terms have no coefficients, but they do. The coefficients are just hidden. X times x to the power of 4 expands to become 1x times 1x to the power of 4. In algebra, when there is no coefficient, it is implied that the coefficient is equal to 1. So back to multiplication. When multiplying, oh gosh, what now?
The invisible one.
The invisible one, right. Yes, I remember that. You're just rushing, man. That's all. Anyway, when there's no index or power at the top right corner of an unknown, it is implied that the index is 1. We must remember that. The expression 1x times 1x to the power of 4 can also be written as 1x to the power of 1 times 1x to the power of 4. Right. So back to multiplication. Yes? Right. Great. When the same unknowns are multiplied, the indices rule is applied. First, multiply the coefficients of the terms. 6 multiplied by 2 equals 12. Then add the indices together. 3 plus negative 5 equals 3 minus 5, which equals negative 2. Therefore, 6x to the power of 3 times 2x to the power of minus 5 equals 12x to the power of minus 2. Now, let's look at a term with mixed variables. 3x squared y to the power of 4z times 5x to the power of 3 y to the power of 6z squared, which is equal to 15x to the power of 5 y to the power of 10 z cubed when applying the indices rule for each respective unknown, meaning multiply x with x's, y's with y's, and z's with z's. Now let's look at dividing. When dividing, you first divide the coefficients as normal. 8 divided by 4 equals 2. Then find the difference between the two indices. 5 take away negative 4 equals 9. Therefore, 8x to the power of 5 divided by 4x to the power of minus 4 equals 2x to the power of 9.
That's it for today's video, but we still have one more thing to show you on simplifying terms. It has to do with equations that involve the use of brackets.
Be sure to check out that video and all the other videos we have here at OpenSec.
This episode of OpenSec Math was produced by the 2 Cents Movement, sponsored by BP, with the help of these people and viewers like you. Subscribe to this channel and turn on post notification for more episodes.